Hey, have you ever seen those giant spinning windmills on land? They're actually called wind turbines. They take the power of the wind and turn it into electricity for our homes, schools, even our video games. Now, what if I told you we're building even bigger and more powerful ones out in the ocean? That's called offshore wind power. It's a super important way we can make clean energy. The wind out at sea is often stronger and more consistent than the wind on land. It blows almost all the time, which means these ocean turbines can make a lot more electricity. That's a really big deal for our planet. Using the wind to make power is brilliant because it doesn't create the kind of pollution that can make our air and water dirty. It's a clean, green source of energy. Offshore wind is one of the most exciting solutions. Just imagine a huge farm of these turbines, standing tall in the water, all spinning together. It's like planting a garden of energy in the ocean. This isn't just a dream. It's happening right now, all over the world. Building these giant structures in the middle of the ocean is a huge engineering adventure. It takes incredible planning, giant machines, and a team of very smart and brave people. From making the enormous parts on land to sailing them out to sea to putting them all together, every step is a major challenge. It's like building the world's tallest Lego tower in a wavy ocean, and the pieces weigh as much as hundreds of elephants. It's a real-life science and engineering puzzle. So, how do we do it? Get ready to dive into the incredible world of offshore wind turbine installation. Before a single piece of the turbine ever touches the water, the adventure actually begins on land. It all starts in massive factories where each part is carefully built. Think of it like a giant puzzle, where each piece is incredibly big and has to be made perfectly. The first pieces are the tower sections. These are huge steel tubes that will be stacked to make the tall tower. They're so big you could drive a school bus through one. They're painted with special coatings to withstand salty sea air and water. Next up are the blades, astonishingly long. Sometimes longer than a football field, shaped like airplane wings to catch the wind perfectly. They're made from strong, lightweight materials like fiberglass and carbon fiber. Making them is precise. Even tiny mistakes can affect how they spin. Layers go into giant molds, resin bonds it all, and out comes a single, massive blade. Then there's the nacelle, the big box at the top of the tower. It's the brain and engine room. Gearbox, generator, and lots of computers. The gearbox speeds up the rotation. The generator turns that motion into electricity. It's incredibly heavy, hundreds of tons. All parts are built and tested on land before the ocean journey. Once the puzzle pieces are complete, they move to a special port by the sea. No small feat. They're too big for regular roads. Special trucks and cranes handle them. At the port, everything is organized and lined up, ready for loading onto giant ships. It looks like a playground for giants, massive white blades and huge tower sections awaiting their journey. To get it all offshore, a fleet of super-capable ships takes center stage. To build something so huge in the middle of the ocean, you need wind turbine installation vessels, WTIVs. These aren't everyday ships. They're floating construction platforms. Giant legs extend to the seabed and lift the hull out of the water, creating a stable platform. You can't build a precise tower if your platform is moving. On deck is one of the most powerful cranes in the world. It lifts heavy tower sections, the house-sized nacelle, and gigantic blades. But these ships don't work alone. It's a choreographed ballet at sea. Captains, crane operators, engineers, electricians, and technicians work around the clock. Foundation vessels install bases. Crew transfer vessels ferry workers. Heavy lift ships move massive parts. A skyscraper needs a strong foundation, and offshore turbines face waves, currents, and wind. The first step at sea is installing the foundation into the seabed. Engineers choose foundation types based on water depth and seabed conditions. Monopiles are enormous steel tubes, up to 10 meters across and over 1,500 tons, heavier than 10 blue whales. A hydraulic hammer pounds the pile deep into sand, clay, and rock until firmly anchored. A transition piece links the underwater foundation to the future tower and provides a work platform with ladders, lights, and safety gear. Getting it perfectly level is essential so the tower stands straight. In deeper water, lattice-like jackets or massive gravity bases are used and secured to the seabed. Whatever the type, the goal is an unshakable base that supports the turbine for decades. Working offshore can be dangerous. Safety is the #1 rule from deck to tower top. If winds or waves exceed limits, work pauses. Computers and alarms back up every decision. With foundations in place and safety assured, it's time to build the turbine itself. The giant crane carefully lifts the first tower section. The crew guides it into place. Giant bolts connect the tower to the foundation. Section by section, the tower grows taller and taller. When the weather window opens, the crane lifts the 400-ton nacelle to the top. The crew aligns and secures the turbine's brain and engine room. On deck, blades are attached to the hub to form the rotor. The operator aligns the enormous rotor to the nacelle, like threading a giant needle in the sky. With the final bolt tightened, construction is complete. A massive turbine now stands tall, a testament to engineering and teamwork. Before full power, commissioning teams verify bolts, electrical connections, computers and safety systems. They test blade pitch and, when ready, give the command. The shaft turns, the gearbox increases speed, and the generator begins producing electricity. Power flows down the tower to a jumper, then through buried inter-array cables connecting turbines like string lights. All power gathers at the offshore substation, an ocean power strip that boosts voltage for efficient travel. Armored export cables are plowed into the seabed and run to shore. At landfall, the cable connects to an onshore substation and the national grid. From the grid, electricity reaches homes, schools, and businesses. Your light switch may be powered by last night's ocean wind. Each turbine adds clean power without burning coal or gas, cutting greenhouse gases and cleaning our air. One turbine can power thousands of homes. Entire farms power cities, creating jobs in design, manufacturing, installation, and maintenance. Engineers push for bigger, more powerful machines and floating turbines anchored in deeper waters where winds are strongest.